This is AP Statistics Chapter 4, and in this video we're going to really discuss how to interpret data because, anyone can compute the numbers, but a lot of statistics is understanding and kind of telling what these numbers mean. And so there's two terms that kind of deal with bias and problems with data, and one is extrapolation, which is kind of when you're predicting data outside the domain of x values. So for example, if we have the numbers, say we have a lot of x values between 1 and 10, this range right here, it would be extrapolation to predict this number here because we don't have this range of x values. We don't really know what the trend of the data is going to be like in this region or in this area. And then another thing to keep in mind are lurking variables. And lurking variables is when variables with an important effect on the relationship aren't included in the variable studied. So give you one interesting example. There is a region that was looking at the number of storks in an area and predicting the number of babies being born based on the number of storks. And we know, yes, storks don't actually bring babies, so the lurking variable was that the storks like nesting in chimneys, and so the more chimneys or the more houses that were around the area, the more children, because there's going to be a larger population. And so here's basically just your basic variable relationships. It's good to keep this in mind for quizzes and tests, just kind of overview it. So the first one is causation, and causation is when your changes in x directly cause changes in y. So a good example is, for your x is the hours you study for a test. So if the amount of hours you study for a test directly affects your percentage on the test. So usually if you don't study at all, you're not going to do as well as if you study for like 3 hours, then you're going to have a higher percentage. And so here, another relationship is common response. So this is when both variables respond to an unobserved variable. And so let's say at fires with a lot of damage, there's more firefighters show up. But the increase in firefighters doesn't cause more damage. It just is all a result of one unobserved variable, which is the size of the fire, because the size of the fire is going to influence the amount of firefighters that come, and it's also going to influence the amount of damage that's being done to different buildings or the area. And then another example, or another type of relationship, is confounding. This is when you can't separate the effects of variables. Usually, sometimes in experiments, it's really hard to separate different variables and have controls for everything. So this is when there's kind of two things causing something, but you don't know which one is actually, creating the change. And so another thing to keep in mind is correlation versus causation. So just because two variables are highly correlated, it doesn't mean that one is causing a change in the other. And something also is only controlled experiments can prove causation. And this topic is discussed more in the next chapter, chapter 5. So observational studies cannot imply causation, only experiments. And then also what we have is Simpsons Paradox. And this is the reversal of the direction of a comparison or an association when data from several groups are combined to form a single group. So an example of this is we have two people, Jane and George. And so Jane makes $5 per hour mowing lawns, George makes $6, and Jane makes $10 per hour babysitting, and George makes $12. And so if you look at this, you're going to expect that George makes more money than Jane just because he's being paid more in both areas. So if they work the same amount of hours, George is going to make more money. What Simpsons Paradox says is, let's see, if they both work 25 hours, who makes more money? So let's say Jane works 20 hours babysitting and 5 hours mowing lawns, and George works 10 hours babysitting and 15 hours mowing lawns. Let's do the calculation. And so $10 per hour, 20 hours, $5 per hour, 5 hours is going to give you $225. And here we have $12 per hour times 10 hours plus $6 per hour times 15 hours is going to be $210. So what we see here is that Jane actually makes more money even though she's being paid less in each area and they're working the same amount of hours because she's working more well-paid hours in babysitting. So Simpsons Paradox is, it's a little confusing at first, but it's really just kind of breaking down the data and seeing and showing kind of discrepancies. So kind of like what you would expect is that George would make more money, but if you really look at and specify the different hours working, you're going to find that Jane actually makes more money.